So, good day students, and welcome to the third nugget on biomass for energy. Today we will talk about which are the residues from agriculture and from silviculture. And we will talk about how to estimate the amounts. You will remember from the homework you did in the first nugget in this lesson that the cultivation of crops aimed only for energy on fertile land is out of question for anyone seriously interested in bioenergy supply systems. So, biomass aimed for energy purposes must always be a side product from food or fiber production. Or it may be a crop that is integrated into a crop rotational scheme, or maybe a protective crop. The resources are treated in the main course literature, which is the Busy Plan Handbook. So go to the web page bioenergyprof.eu and then click the menu item Basics. Scroll down a bit until you find the Busy Plan link in the sixth text paragraph. Then click that link to arrive at the Busy Plan homepage. The handbook is structured as a matrix, and as you will see is the second column devoted to the resources of different types of biomass. This nugget concentrates on the resources of lignocellulosic biomass, that is mainly woody biomass, and then the nugget focuses on biomass from agriculture, and that is mainly herbaceous biomass. So chapters 2.1 and 2.2 are the main literature for this nugget. The nugget will also introduce you to the Busy Plan spreadsheet. The spreadsheet is downloaded from the Busy Plan homepage. So download the Excel file to your own computer. Then activate editing rights for yourself and then unprotect the spreadsheet using the password BusyPlan. But then be very careful only to fill in the yellow cells, and whatever you do not erase anything. Once you have done these things, you will be set for this nugget. Now stay in the spreadsheet and scroll down to find a table. You will see that this table contains a column called RPR. This is the residue to product ratio, which is used to estimate the amounts of residues from crops. And then look at the handbook, chapter 2.2, table 2.2.1, and here you will find the same thing. In agricultural crop production, the main thing, and the thing that is kept track on, is the yield of grains, or whatever commercial product is aimed for. It may be cereals like barley for beer production, or wheat for bread. It may be rice or grapes, or just anything. So that is the main commercial product, and that product is controlled, weighed and sold. But in the energy context, we are more interested in the side products. These may be straw, stalks, cobs, shells, stones, husk, or any other non-edible side products. So what the residues to product ratio aims to tell is how many kilo of residues do we find for each and every kilo of the main commercial product. So the RPR is a crucial value. The problem is that this value is not given by nature. So though general estimates are available from different sources, you will always have to be very critical to such values. If you want to make a thorough estimate of the potential resources in a certain region, you would be advised to do some field trips and try to confirm the RPR values that you have found from literature. We will discuss this a bit further in the homework session of this nugget. There are also other local and regional factors to take into account when you are making resource estimates. Some such factors are the removal rate, competing uses of the residues, and the quality of the material. These factors are discussed briefly in chapter 2.2.1 in the handbook. The quality of the material is of course depending on the type of crop, and different types of crops are discussed in chapter 222. As you will see in text section 222a, there may also be some types of agricultural crops that belong to the category of lignocellulosic plants. So this marks a natural crossover to the woody biomass. Woody biomass is the main scope in the handbook chapter 2.1. Generally speaking, wood is used in three major sectors. First, the thick stem can be used for building, construction and carpentry, such as furniture or other types of consumer goods. This is called timber or lumber. Typically, the stem is sawn to planks of different dimensions, which are then dried and used in the wood industry. Miscolored wood, as well as wood of inferior quality or wood too thin for sawing, is mainly chipped and used for paper pulp. Thin material, like branches, tree tops and the like, are used for firewood. Depending on the industrial structure, may the proportions between these three major sectors be very different. In Sweden, where the forest industry is a base industry since centuries, will approximately 40% of an annual felling be used for timber, and about 40% be used for pulp. And then will some of the material going to the sawmills be lost in the form of sawdust and shavings and such. And this will be outlined in section 2.1.5. The different fractions will to some extent have different properties, and you may want to read text section 4.1.3 to get a first insight into this. Just like there are competing markets for the agricultural residues, as outlined in text section 2.2.1c, can the woody residues be used for different purposes, as mentioned in section 2.1.2c. Now, scrolling down the spreadsheet, you will hit a headline saying Forest Regional Resources. Below that, you will again find a table to help your calculations. This table is mainly aimed for short or medium rotation copies, and you will find these systems described in the handbook, section 3.1.2. As you will see in the table in the spreadsheet, you will have to give some specific measures for the grown-up tree, and you will also have to specify the species and the number of stems per hectare. It is obvious that the number of stems per hectare, that is the spacing between the trees, will be a crucial factor. For old stands of grown-up trees, this number is typically somewhere in the range 1,000 to 2,500 stems per hectare. That means that each tree has some 10 down to 4 square meters for itself, so the spacing between the trees will be some 2 to 3 meters. In dry conditions, will the number of stems per hectare have to be reduced and can be as low as 2 to 300 per hectare. So then will the spacing between the trees be some 5, 6 or even 7 meters. In the case of shrub, will the spacing be down at about 1 meter. But lignocellulose is also a byproduct from fruit orchards, viticulture and other plantations. Prunings from fruit trees, olive trees, vines and other utility plants may represent a significant resource in some regions. And in these cases, will the headings in the input table shown in the slide not be applicable. But the table can still be used, just that you will have to adapt your input properly. So you cannot even make the first estimates without having some basic knowledge. And this is what the homework will be about.